Welcome to our OpenPOWER Academia and Research Big Data and AI webinar series. Thank you all for joining today's webinar, and my pleasure to have you all here. Today we have Dr. Alba from University of Brasilia, Lutz Kirchner from GTS-DATA Europe, Heinz Koster from Brazil, and Sandhya Palani from Object Automation to share their experiences on big data, AI, and cloud platform using OpenPOWER systems. We have our special guest as panelist, Dr. Argya. As usual, he has been spending a lot of hours, for this webinar from University of Wisconsin, and also Dr. Jayaraman from IIT Madras to be as panelist, for this webinar. And Jayaraman will be joining a little later. And today's session will be recorded and shared. Question and answers will be at the end of the first as well as the second presentations. You can raise your hands as well as you can post questions in the chat window. As part of today's webinar, the first presentation is about combining cross-national assets and skills in recent times for customer benefits by the three partners, who have been working with the OpenPOWER Academia and Research team for the past few years. And the founder of, the GTS-DATA, Lutz Kirchner, and Heinz Koster, senior consultant, and also, Sandhya Palani from India, the Object Automation, will be sharing their experiences. Heinz, please go ahead and start your session.
Okay. Thank you very much for the introduction. Bom dia para nós brasileiros aqui. Good morning, good afternoon, depending on the time zone where you are in the rest of the world. Yes, what we have prepared for today, we would like to present our experience and possibilities here in Brazil. We have spoken about Raptor Brazil. Lutz from GTS-DATA will show MacBot from FormSet as a service, especially for those who need data center capacity and have not the budget to buy new hardware. Is this a very interesting alternative? HPC as a service, and later in the context, maybe this is a question to the group, Power 9 as a service might be interesting too. Then Object Automation will bring in experience and which services they can offer in this triangle. And at least we want to show at least the partnership, your benefits, and speak about your expectations. And Lutz has enough time, about 20-30 minutes, to show MacBot a little bit more from the technical side, which possibility it delivers, which cases are possible to evaluate, and how to bring benefit into your daily business. You have seen the slide before. These are the three who speak to you today. It's Lutz, Sandhya from Automation, Object Automation, Lutz, of course, from GTS-DATA, and me from Costa TE here in Paulínia, Sao Paulo. Just two slides to what we are doing here in Brazil. We are the official partner of MariaDB in Brazil. We are official partner of FormSet. It is one of the most innovative provider for big data analytics solutions in Asia, coming from India too. And we are working together with developing solutions in the direction of ADAS, autonomous driving, together with GTS-DATA, with the now I've lost it. Object Automation, bringing in his experience in this area, and GTS-DATA to put MacBot as a service or as a solution into the car. And here we are in close partnership with one of the leading hardware provider. And at least we provide consulting and management for those who need another idea, another objectives, and ideas from other point of views. We are established in Paulínia near Sao Paulo, Campinas, and working from here. So I think it's a new step to go forward with these solutions in Brazil. I think part of you know this hardware. We are staying in close contact with Raptor, and we've the concept to buy their main board, the Power 9 processor, and other essential parts in the States. We want we combine these parts with local products we can buy here because it's much more cheaper. And we have a local assembling in Brazil. Doing so, we can reduce the cost and import taxes, which are quite high. And at the moment, with this exchange rate, make it much more difficult. And we can offering local guarantee to you using these machines. And of course, you have the chance for individual configurations, not just to buy the machines they offer in the States. And the motivation, our motivation together with IBM is that we can offer you very competitive pricing for these machines you can use. As we've said before, as Ganesan has said in his introduction, we are 3 partners. Here are 4 because FormSept is one of the solutions GTS-DATA is providing. And yes, together we can give you a solution. We can offer you services which are difficult to find with these combinations. And with this flexibility and speed of realizing, FormSept is really leading in intelligent solutions of charging technology for electronic vehicles. It has long experience in, we call it something like intelligent city solutions, intelligent parking services, and at least it has a strong experience in AI and breaking up video streaming from the sensors at the cars, that these videos get been solved and used inside the car and not outside. Object automation is bringing in really excellent consulting services, back office services, and experience in others, and AI consulting. There you can get more information later. I, from my side, bring in the before explained experiences and bring the other partners together here in Brazil, that we have these complex solutions easy used in Brazil. And Lutz from GTS-DATA is offering the data center, and here we write secure data center capacity and services based in Germany. Secure because it's not public cloud, and especially when you are using and working with secret data, this is a really interesting alternative for every other on-premise cluster, but you can use it as a service. And here he has 3 levels: MacBoard, HPC, and Power 9 as a service. And yes, he will explain later in his session. So here you see that we are covering all time zones over the world. GTS-DATA in this case in the middle in Europe, acting from Europe, my side from the time zone Americas, and object automation in the region Asia. So for those who need fast response and more support than just office hours, we can help them too. Here, just for benefits for you and for our customers, we can combine the best pricing models for you. We are working on standards which we offer to other customers around the world. And here, especially in Brazil, we can benefit from it. Lutz, with his data centers, bringing in international security standards like TISAX, which is quite important for the one or other use case. And we are combining the advantages and adapting it to every region where it is used and needs to be used. We see each other as agile partners, small teams, so we can act faster than the really big good ones. And yes, I think you will see later there's passion. We use to realize our projects. We are innovative. You will see later in the part of Lutz. And yes, we combine everything that you get your solution you need and your service you need to realize your daily business and to find the best solution. As I said before, we can offer you 24/7 support. We are combining our experiences, developments from each market. And so we are, I can say, in front of the others. These are, sorry, just my contact data, and this would be the part. Yes, I see there's one question. Maybe Ganezan, you can take over, because this is now the step that I can give my word to the second presentator. Thank you very much for now. Any questions?
Hi, good morning. I am Argo. So I have a question regarding the solution that you provide.
Yes.
So thanks for the wonderful presentation, first of all. And my question is regarding, do you have any Raptor solution which are focused on university research or university education, something like that?
I know from Ganezan that we have these solutions, and after this session, we can give you more detailed information to this. Yes.
Okay, perfect. Thanks.
Other questions? Then, Sandhya, you will take over, because now it would be your part.
Yes, Mr. Heinz. Thank you.
Thank you.
Thank you so much for the great introduction about automation. I like to share my screen. Hey everyone. Thanks for giving this opportunity to share our experience in big data and AI solutions and trainings. Our company founded in 2001, and I've been working on application development, big data, AI solution development, and trainings. With trends and latest technologies, we are providing solutions and services in different areas, especially we noted in hardware, we are setting up AI labs with AC922 server, and we do support other servers with IBM partnership. We provide software solutions, providing AI solution for different sectors, internship trainings, and educational support also. Our core team in India has been working to deliver solutions to our clients on Hadoop, Big Data Analytic, Internet of Things, storage solutions, and data science. We have in-house AI infrastructure as well as AI infrastructure available on cloud. We have enabled several thousand people in AI, big data, and cloud technologies on IBM and NVIDIA. we have been setting up Center of Excellence in blockchain, IoT, quantum computing with the support from IBM, NVIDIA, and Intel. Also provide consult services without technical. These services mostly on deep learning and machine learning. Our technical team recently developed some solutions with AI technologies. The first one is about latest COVID-19, which we are which we are going through now. We have developed a prototype where one can go online and provide their lung X-ray image as an input to the model, which could deduct the probability of the infection in the lungs. This is just a prototype. Those who want to try it, you can reach us out actually. Separately, you can reach us out. And the next one related to automobiles also, we have a solution. We also developed a solution called ADAS, Advanced Driver Assistance System. This prototype with the ADAS openly available data which can detect collision warning and automatic braking, speed alert and assistant parking and so on. This prototype, what we put together, can be enhanced based on the client's requirement. We have developed and tested this prototype using IBM Power 9 with NVIDIA V100 GPU. Again, in healthcare industries, we have been working with an hospital in India. We have got 60,000 plus retina images and developed a deep learning model using IBM Power 9 systems and deployed them on the Jetson Nano Edge device. Doctors can use this Jetson Nano device and upload the retina image from patient and immediately provide the AI result. The next solution we developed is face recognition at edge. This is used for automatic attendance in institutions to maintain ledger for each class or the department or subjects. This solution is developed by deep learning using IBM AI system and deployed in Xilinx Ultra 96 edge device. So these are the clients and partners, business partners. Do we work with them? And our educational partners. And fine with this, we have into our presentation and thanks for your valuable time. Sorry, I hope I went through the slides very fast. Do you have any questions?
Yeah, thank you, Sandhya, for the update. And maybe we can take the question at the end of this, the first presentation.
Okay,
yeah.
sure.
Thank you, Sandhya. And please, Lutz, please, go ahead and start your presentation.
Hi there, everyone. I'll try to share my screen now. 1 second, please. Got to take the right one. So I hope you can see everything.
Yes.
Well, hi there. Thank you for the opportunity of having me here. It's an honor for me because I think we have some very nice solutions we can provide to you. And well, just let me run you through them, what we have up our sleeves. And the first part, I want to present you our HPC as a service structure, as well as the CEA structure we have. So we are a small company based in Germany, which specialized in HPC services. We don't want to compete with the big global players because we don't want you to be an anonymous number up our technical alley. So we are a personal solution. You can talk to us. That's what is quite nice about us. So, but don't underestimate the power we have in our back. So I will show you a little bit of installation we have on my next slide. And so you see, we do have some interesting capabilities and cluster nodes up our sleeve, which you can use in a modern solution, which is nowadays always based on time consumption and computing power. So we have the newest AMD Rome CPUs at hand. We also have the newest generation of NVIDIA Tesla GPUs, which we can use for AI and deep learning situations. And that's just our major business. But that's not the main thing I wanted to talk about today. Today it's all about customer-centric and client-centric solutions. Often you have different vendors, as you see in the screen, and we want to bring you together. We just want you to have one person you have to attend to for your solution, and that's what we actually do. We partnered up with some interesting companies at the moment, and that's what we do right now. We also partnered up with Garnisan, Heinz, and the company Formcept, so we can provide a more big data driven solution at the moment, and that's quite interesting for now. And now, are you there? Hello?
Hello, we can hear you.
I think we lost him.
Hey Ganesan, I think we lost Luke.
No, I'm here.
No, I mean, I
Look,
think we lost.
Sorry,
yeah.
I just got thrown out of the Zoom meeting.
Okay, great.
One
Okay.
second. I'll continue in a moment. That never happened before. Well, it's always the first time. Okay, here we are again. I hope you all see my screen now. The main 4 key advantages we have is the great efficiency with the combinations of hardware and software stack we have. So you even get a shorter time to market phase and some additional innovations. But what we actually wanted to talk about today is our end-to-end augmented data management platform. I think that is a very interesting solution for data scientists and everybody who works with a lot of data. The catchphrase augmented analytics is nowadays in everybody's portfolio, and I think we have something that is very, very interesting for you, because you don't have to buy it. Actually, the software we provide it as a cloud service, so you only pay what you use it for. This is a presentation of how and what kind of data we can process with the MacBot solution we have. It's unstructured data and every kind of data you can actually use. As Heinz mentioned before, we are currently developing with one of the leading hardware vendors a technical solution to manage the data inside the car for autonomous driving step 5 and 4 as well. So that's a quite interesting solution where we have video analysis and image recognition and all that kind of stuff, which is actually happen within the car. You only have to download a small percentage of the data to your normal cloud solution, so you can train the models actually. And that is a very, very interesting thing to do. This is a little bit of an overview how the MacBot is, what its key benefits are. And the funny thing is, you only need about 14 to 15 days to set it up, and it will generate results from the first day. It actually runs with its full capacity. And so you have various systems you can run it on, as you see, Red Hat, CentOS, Ubuntu. You can use it quite slick. It also has different techniques integrated, such as the management, the enhancement, self-discovery solution. So you don't have to do everything by hand. And I think that's in our nowadays solutions very interesting, because you can save a lot of time, because it's always one hell of a job to go to every analytics, see what data you can connect, and MacBot does that a lot of things by itself. So you have some insights you really wouldn't think about at the first side of the data. Now I want to show you some cases we already handled and which we implemented MacBot in. It's quite interesting. In the energy sector, we do analysis about the grid load and predict how the grid is actually being loaded when a music event takes place, or a festival or anything like that takes place. We also do some analysis for legal obligations. It's a contract oversight, sports analysis. It's quite interesting what we actually already have done with this solution. I can provide you later on with some YouTube videos where we go into detail what we have done. We also did a interesting showcase with ChargePoint. They use MacBot as their central data platform for almost everything you can do with it. ChargePoint provides charging stations for electric vehicles, and they have a complete infrastructure where you can use the provided app to save a charging spot on a local charging station. And it's also, the billing is provided by the app, and all data is handled by MacBot. This is a small view into the details of MacBot, how it's constructed, what kind of technologies it uses, and actually what kind of performance you can get out of it, and what you can also put on at the end of the data line to let the data flow into, like ClickView, Tableau, or Power BI. We put our solution in front of that, because it's we glean the data. We also provide a search engine with neutral language, and that's quite interesting for some customers. As you see, it's a one-click solution. It truly is. Well, it's not a click, it's a code line you have to enter, to be honest. But it also scales up to petabyte to process data. That's quite interesting in nowadays, because, well, let's be honest, data is not getting smaller. We talk about big data today, and I think that's, well, the future. We will get more data and more data all the time. So yeah, I think you see what we actually can process on the left side, from unstructured data, semi-structured data, and structured data out of a database. It's nearly limitless. We in the ADAS construct we are developing, we actually directly access the CAN bus, so we can use the nearest entry point to the car data and pull them into our MacBot solution and process the data on this level. Yeah, so that's a little bit of a technical overview. I think it's more interesting for you to ask me some questions at this point, because I think it's gonna be interesting. So please go ahead, ask questions.
Lutz, thank you for the presentation. And
You're welcome.
audience and participants, any questions for Lutz?
I think there is a question in the question answer window.
Okay, Lutz, there is a question actually, from Gautam Kumar. What is the main theme to construction of MechBot?
The main theme is that it is a analytics platform with which levels out the complete use of the different data platforms. I'm not sure what he actually means, but by theme, to be honest, I'm sorry. But we try to provide a normalized and a centralized data access platform, so you don't have to use a lot of different systems. It all comes into one solution.
Okay, I think that answers the question actually. Basically, what is the goal of MechBot? That's what I mean. I mean, I hope the Gautam Kumar means. Okay, and another question we have here, related to the talk, whatever we had. Day by day, data grows exponentially. How to handle such a high volume data?
We have specialized storage solutions in the background, providing a very fast access to the data. It's based on a SSD storage solution provided by one of our partners, which actually gives us the speed to handle all the data in real time. Yes, real time is in captions being said because some data amounts are too big to handle in real time. But I would say about 70% we can truly handle in real time if the data is flowing in simultaneously.
And maybe I can add another point. MechBot is screening, processing, and filtering the data that just about 10% of the total sum of data needed to be used for the next steps, and the rest of the 90% could be stored on cheaper storage systems. So this is a second advantage of using such a solution.
Thanks, Heinz, as well as Lutz. Let me look at another question right now related to the talk. How does MechBot consolidate the data from cloud?
Well, we have several APIs which can access them. We use a screening process. Let me look how we actually use it to tell you in. Sorry, forgot the words. There is we built a tool which actually handles all the mounted data points, and it takes in the data second by second. So we have an active collecting process which gathers the data and then puts it into the pipeline where the data is processed further on. I hope that answered the question.
Yes, thank you, Lutz.
You're welcome.
And
I think the question before is quite interesting, how we, or you, Lutz, in this case, handle the confidentiality and security of the data of the users.
That is quite interestingly handled. You can bring your own key as one of the bases. So you provide the key which is imported into MechBot, and the streamlined data is always secured by your own key. We can't actually access the data itself if you don't give us the permission or your private key in that point. So you have the data security at your hand. You always will own the data. We are not looking forward to encapsulate the data with our services. You can always have the data back. We securely erase the data if you ask for it. That is all being built into the process. So we have a very high standard of data security, not only by law, but on several other occasions. The German data protection law is also very strong. Yeah, no, it's not a certificate, but it's actually the law. So we have to abide by it.
Yes, and I think, as we've said before, additional international standards like TISAX certifications help to give the customer the security that the data are safe and not used by others, because TISAX is one of the highest data security level in the world, especially for data center.
Yep.
For the question
right.
of how the latency is handled by the autonomous car, I don't have the data at hand. I would have to look it up, but I can provide it for you after the webinar. I'll have to look it up. I don't have it at hand. I'm sorry.
So I have a quick question.
Yeah, sure.
So when you are talking about complete solution, so what are you pointing to? I mean, do you ship the entire hardware to your client with all the software installed in it, or do you offer like a cloud-based type of solution, or do you have like some kind of, let's say, virtual software stack that's the client can install, client can download and install, and all these things? Or you work in all these three domains?
We actually provide all three solutions. Yes, we do. We have a cloud solution at hand. We also can install our software solutions on hardware provided by our customers, and we also provide a complete solution stack from hard to software. We handle all three cases because we think it's for the customer the best approach, so they can choose if they want to use the platform we provide on a daily basis or an hourly basis. They can also access it via REST API. So we have a lot of nice solutions. We always come to the customer and talk to them what would be best for them. If they need a short-time solution, they don't need it all the time, it would make no sense for them to buy a whole hardware stack. So they can come to us, use our infrastructure, and it's a private cloud. It's not a public cloud, because we are very particular on our safety standards and security standards. So that is a very centric thing in our company. So we, as I said, we provide every three solutions.
That's great. Thanks. Thanks for the answer. And I have a request to all the three speakers. Is it possible to send the link to the website or some kind of document from where I can know more about your services?
Yes, of course, we will do.
Okay, thank you.
Yes. No problem.
Yes, we can do. Yes, sure.
Sure.
Thanks.
Thanks, Professor Agya. And any more questions? There are a few more questions are there on the chat window, Q&A. And there is a question about, the 5G. Is it functioning of cloud in 5G? From Professor Rajaram.
Yes, we can use 5G within our software stack. That's no problem at all. We tried that with the ADA solution, and it works quite nice. Was an interesting test for us, for ourselves, and we were very surprised how agile it was.
Thanks. And I'm going through the questions again. Hold on. Yeah, there is a question related to, can I know more about the role of AI in automobile? That is actually, You know, anyone can answer that from that group of 3 people?
Okay, I'll go.
Yeah.
Well, you have a different kind of decision models in a car, whether you have a obstacle in the road itself has to be well analyzed and processed. So everything the human mind thinks of viewing the road, the surrounding of the road, is actually a model which can be trained by an AI or can be trained into an AI solution. So you have very wide, it's a very wide range in the automobile for AI, which can be supported by AI and actually can be processed by an AI. One of my things I always think about in my youth, I watched the series Knight Rider with the self-driving car. It's about 25 years old, I think. And nowadays I realize actually what it means, what a car has to do to consider going down a road and what kind of AI capabilities you actually have to do that. It's quite interesting. I
Yes,
hope that answered that.
and additional to this, there was this first hype of AI, introducing and using AI technology in the industries, which was just like learning and then testing. And the companies made the experience that the technologies are not in that stage they were expecting. Now, with these experiences, AI is coming back, and the companies are thinking more seriously about using these technologies, which helps us to bring in another level of services and level of consulting and expectation. So I think it's not lying. These new technologies without AI would not work. And we are at that step that it makes sense to use them, and that this is a really big and serious help now in technology.
Thanks, Heinz, for the wonderful you know, response to this question related to the AI in automobile. And you know, the remaining questions, you know, we will answer through, you know, the email, as well as, you know, maybe later during the session, you know, we can answer too. Let's move on to the, you know, the second one. Before that, I'd like to thank again, you know, Heinz, Lutz, as well as Sandhya Palani for their wonderful, you know, the presentation and also sharing their experiences. Thank you again.
We thank you for the
Thank you very
opportunity.
much.
Yeah.
Yeah, thank you very much for
And
being
you all
here.
welcome. Yeah, you all welcome to stay back. We do have, you know, before you know, our second presentation, you know, some more minutes. So I have an interesting, you know, person, you know, who is going to share uh, some of his experiences working with the OpenPOWER Academia for the last several years, nearly I would say 3 years. You know, he worked with me, you know, in the journey of, you know, the OpenPOWER Academia and research, and, you know, collaborated with us on the platform, you know, in many ways. And he's also right now my colleague, Rohit Mule, and he's going to be sharing some of his experiences. Rohit, please go ahead.
Yeah, thank you, sir. Am I audible?
Yes.
Yeah, so yeah, it's a great pleasure to be one of the panelists here. And I've been working, as sir rightly pointed out, from past 3 years with him and in various projects. So I also got an opportunity to visit University of Illinois Urbana-Champaign and work under Professor Venmai as a part of IBM OpenPOWER Research Foundation. And there are a lot of things which I was able to discover within myself, with a lot of opportunities as I studied and I interned, and right now as employed. So there are a lot of things which every student can learn, and this has really opened up a lot of opportunities for me, and it's been an amazing journey. So we have some of our like the journey until now. We have a video about it, so I would like to share my screen. Let me try sharing my screen. Uh, okay, so I'll have to give some permissions to share my screen. Give me a minute. Oh, okay.
Or Rohit, if you want, we can have your video presentation later after the Professor Alba's session.
Yeah, hello.
Yeah.
Yeah, I'm sorry about that. I was kicked out of Zoom when I was sharing my screen. So yeah.
No, do you want to do it now?
Yeah. Yes.
Oh,
Yes.
okay. Okay, go ahead, please.
Yeah. Okay.
Sure.
Okay.
Volume, please. As part of OpenPOWER Academia and Research, we have been running hundreds of workshops and webinars worldwide for last 7 years. And this is a great opportunity for all of us to work with many researchers, industries, and leaders and students to work on this massive open platform for AI, HPC, and cloud. I also like to mention a few things about Summit Supercomputer. It is based on IBM Power9 Oak Ridge National Lab and #1 supercomputer in the world. This system represents the culmination of a significant collaboration between OpenPOWER Foundation members, IBM, NVIDIA, Mellanox, and Red Hat, with the goal of producing a well-balanced computing platform for not only traditional HPC workloads, such as modeling and simulation, but also AI and cloud workloads.
We purchased an OpenPOWER cluster for deep learning. We had a lot of students and a lot of faculty doing research in many different areas, and they have a lot of data. Obviously, deep learning provides them with a way to extract information from that data that allows them to do new things. So we purchased our system, came on the floor in February of this year. It's been used quite a bit since then, and IBM came to give an OpenPOWER workshop, which has been really useful. We had a huge amount of interest from the students and the faculty. Basically, we're trying to get the word out and get people with some hands-on experience with deep learning so that they can take it and apply it to their research in different areas. It's been a real great experience. I think there's a lot of exciting things going on in this field. Obviously, the software changes very quickly. There's been a lot of disruptive changes on the hardware side, and working with OpenPOWER and Power AI gives us a way to take advantage of the changes in architecture through software without having too painful of a process. So I think that's what we've really been able to get out of it so far.
I am Arghya Kusum Das, an assistant professor of computer science at University of Wisconsin, Platteville. I got my first exposure to IBM Power System when I was doing my PhD at Louisiana State University in 2015. My research was a study of scalability and cost effectiveness of large-scale scientific applications over heterogeneous computing environment. So I was mostly working on bioinformatics domain. That time, despite multiple prior attempts on existing Intel-based HPC cluster, we could not analyze a large metagenome dataset in a reasonable period of time. So knowing the capabilities of big data analysis offered by IBM Power Systems, we turned to IBM for help. The performance of the system was surprisingly good. The huge 3.2 terabytes of metagenome dataset was analyzed in 6.25 hours using only 40 nodes. So that was kind of a great performance for us at that time. Then I joined University of Wisconsin, Platteville as an assistant professor and started collaborating closely with IBM and OpenPOWER Foundation for my research, teaching, and also for my own visions. This collaboration enabled me to work on world's fastest supercomputer summit at Oak Ridge National Laboratory, which is helping me accelerating my big data research in the domain of bioinformatics, genomics, and healthcare. Then as an educator and big data and HPC enthusiast, one of my visions is to contribute towards the global demands of data experts. Now to materialize that, I am actually launching my own online education platform. In collaboration with OpenPOWER, I am currently working on the pilot phase to develop innovative curriculum and learning outcomes to spread the data and HPC education to meet the worldwide need for experts in the corresponding fields. So, and also we are organizing big data workshops, webinars, hackathons, which will provide a forum for disseminating the latest research, as well as it will provide a platform for the students to get hands-on learning and engage in practical discussion about big data and AI-based technology.
Okay, so this is actually a complete journey of OpenPOWER Foundation. You can find this video right after this meeting on our YouTube channel, OpenPOWER Academia and Research Revolution. So if you just go to YouTube and see this channel, please do hit subscribe button so that you'll be updated on the latest technologies of AI and machine learning. That's all from me. Thank you.
Rohit, thank you for the wonderful video which you spent, a good amount of time, to create it. Thank you very much for all your effort on this, and thanks for sharing your journey with OpenPOWER too. Thank you. And audience and participant, panelists, let's move on to the, the next speaker, the next session. Our second talk is going to be given by Dr. Alba Cristina, professor at the University of Brasilia. She'll be sharing the parallel biological sequence comparison in GPU platforms. It is a part of our, research at the University of Brasilia, Brazil. Professor Alba Cristina, I'm not able to pronounce her full name, Di Mello, obtained her PhD degree in computer science from the Institut National Polytechnique de Grenoble, France in 1996. Since 1997, she is with the Department of Computer Science of the University of Brasilia, Brazil, where she is now full-time professor and vice head of the department. Professor Alba, please start your presentation.
So good morning, everybody. I will share my screen just a little bit.
Yeah, very nice. Thanks for turning on the video.
Thank you very much. Yeah, I will try. Depending on the bandwidth, I will turn it off, but I try to do. Okay. So can you see? It's okay?
Yes.
So first of all, I would like to thank Ganesan Narayanasamy for inviting me to give this webinar. And I would like to thank all of you who are here watching it. So I will talk about parallel biological sequence comparison in GPU platforms. It is related to supercomputing. And I will show the research that we are doing at the University of Brasilia. So first of all, what is a biological sequence? The biological sequence, they are obtained with a specific machine, which is called the sequencer. And we put the samples in this machine, and you can see here on the top left side of the slide, the quality of the samples. If the quality of the samples is good enough, we go through the other steps, and the last step is the chromatography analysis. And with that, we obtain the DNA sequence that you can see here on the bottom right corner of the slide. But this is not the end. This is just the beginning. Now we have the sequence, but what does it mean? So when we obtain the biological sequence, we need to establish the properties and the characteristics of the sequence. And this is done by comparing the sequence with the sequences for which we have already, we know already the properties and the characteristics. So the comparison of biological sequences is one of the most important operations in bioinformatics. What we want here is to define how similar the sequences are. And why we want to define this? Because if the sequences are similar enough, we infer that they have the same properties and characteristics. So there are exact algorithms that compare two sequences and they produce the optimal result. they execute in quadratic time, and they have quadratic memory complexity. So it depends on the multiplication on the sizes of the sequences. Heuristic methods are faster. They are used in many genome projects, but they do not produce the optimal result. In this talk, I will talk about the optimal result. Smith and Waterman, they proposed an algorithm that is based on dynamic programming, and it's able to align two sequences. It produces the optimal result since it is an exact algorithm, but if the sequences are long, we can have high execution times and huge memory requirements. For instance, if we want to compare the human chromosome 1 with the homologous chimpanzee chromosome 1, and here we are talking about 249 millions of characters compared to 228 millions of characters. Using this traditional algorithm, we would need at least 240 petabytes of memory. And in 2008, I was in a conference talking to a lot of researchers saying that I would like to do this comparison with this algorithm, and everybody said that it was unfeasible. And I will show you why they say that it's unfeasible, and I will show what we did to do this comparison in reasonable time. So the goal of this talk is to present and discuss our CUDAlign tool to compare huge chromosomes in GPUs. I will show you that we use a highly optimized algorithm to exploit the parallelism. And for the sequential part of the algorithm, we use speculative techniques. I will show you also that we were able to use up to 384 GPUs, and we were able to compare the human and chimpanzee homologous chromosomes in 2016 in reasonable time. I will also show some preliminary results of the next version of our tool in the IBM platform with Power 9 and 8 NVIDIA Volta. And then I will briefly discuss our results, MASA OpenMP, only in CPU for smaller sequences in the Power 9. I will show you some comparative results and some very preliminary results on COVID-19. So, in order to compare two sequences, we will place one sequence above the other and compute a score. Here you can see two sequences, S0 and S1. S1 has 11 base pairs. Since it is a DNA sequences, it has a double strand, but we only consider one strand. So for this talk, 11 base pairs is 11 characters. You can see here the alignment of the sequences. If the characters are the same, this is a match. The value assigned for matches in this example is +1. If the characters are not the same, this is a mismatch, and the value assigned for mismatches in this example is -1. We can also introduce gaps in one of the sequences, and there is a penalty for doing that, and here the penalty is -2. The scores obtained by adding all the values, and here you can see this alignment has score 6. But of course, we want the alignment that has the highest score. And this is done by the Smith-Waterman algorithm. It is based on dynamic programming, and as I said, it has quadratic time and memory complexity. It executes in 2 steps. The first one is to compute the dynamic programming matrix and to obtain the score. The second step is to do the traceback using the dynamic programming matrix and obtain the alignment. So how do we compute the dynamic programming matrix? With this recurrence relation that you're seeing here. The first and second terms consider the situation where we introduce gaps in one of the sequences. The third term, we compare the characters. If they are the same, you assign the match value, otherwise the mismatch. And we need a maximum between these 3 values and 0. So it's very simple. Here you can see an example. You have 2 sequences, S0 and S1. S0 is placed on the horizontal and S1 on the vertical. We fill the first row and column of the matrix with 0, and then we use the recurrence relation that I just showed you to compute the other cells. We also keep track, the rows that you're seeing here, we keep track of the cell that produces the value. Can be 3 possibilities, up, diagonal, and left. We compute everything and we end step 1 with the maximum score, in this case 4, and the position where it occurs. Then we start stage 2. From this position, we follow the arrows, we build the alignment from the end to the beginning until we find a cell which value is 0, okay? So it's very simple, but imagine that we have 229 million characters in the vertical and 249 million characters in the horizontal. So that's our problem. There are some Smith-Waterman variants that we use it in our tool. GTS, it computes a more complicated gap model that is called the affine gap model. In this case, we assign a higher value for the first gap and a lower value for the other gaps. In the GTS uses 3 dynamic programming matrices instead of 1, and it provides a better biological result. Time and memory complexity are quadratic. Hirschberg in 1977 noticed that if the sequences are long, the quadratic memory complexity will be a limitation. So he proposed a linear memory algorithm that uses a divide and conquer recursive approach. So time complexity is quadratic, but memory complexity is linear. And finally, Myers and Miller in 1988 combined these 2 algorithms and in an algorithm that computes the affine gap model in linear memory, okay? But we want to do this in parallel. So in order to do that, we need to analyze the data dependencies. And the data dependencies are here. So each cell Hij depends on I-1 j, I-1 j-1, and ij-1. So we cannot compute every cell, all the cells at the same time. There is data dependency. So at the beginning, only the first anti-diagonal, D0, is computed. It's the blue cell. Having computed that, we can compute the cells, 2 cells in parallel, the cells in red, and then the cells in yellow and so on. I hope you are seeing a wavefront over the anti-diagonals of the matrix. What's important here is that the parallelism is very small at the beginning, then it increases up to the main anti-diagonal, and then it decreases again. At the end, we only can compute 1 cell at diagonal D6. So I will show, I needed to explain that before talking about our tool. Our tool is CUDAlign. The goal is to compare huge DNA sequences in GPU with a combination of GTS and Myers and Miller. We did some adaptations in these algorithms too. And we have many versions of this tool. The first one is CUDAlign 1.0. We will compute the similarity score in 1 GPU. That is the step 1 of the algorithm. CUDAlign 2.0 will compute the score and the alignment in 1 GPU. That is the step 1 and 2 of the algorithm, the complete algorithm. And then CUDAlign 2.1, we will compute the complete algorithm in one GPU, but we added pruning capabilities. Then we went to several GPUs, CUDAlign 3.0, only step 1, the similarity score, and CUDAlign 4.0, at the time it was called already MASA CUDAlign, and where we compute the score and the alignment in several GPUs. So this is the PhD thesis of my former PhD student, Adam Sanders. This thesis was awarded the best PhD thesis in computer science in Brazil in 2016. And one paper from this thesis received the Wilkes Award 2019. It is the best paper published in the Computer Journal in 2018. Okay, so I will show you how MASA CUDAlign works in one GPU. Stage 1, it executes in 5 stages. Stage 1 will compute step 1 of the algorithm, that is the compute the dynamic programming matrix. And then stages 2 to 5 will do the traceback, that is the second step of the algorithm. So how do we do? We will compute in GPU the dynamic programming matrix. We will not store all the positions. We will store some rows only, and we will find the maximum score and its position that you can see in red. At the end of this stage, we have several rows and the score and the position where it occurs. Then we will go to the traceback that executes in 4 stages. The first stage of the traceback is stage 2. So we start from the position that has the optimal value. We read the row that's closer to it. We recompute until we find a point that belongs to the optimal alignment and crosses this row. This is what we call the cross point. Having this point, we read the row that's closer to it, recompute until we find the cross point, and so on, until we find the beginning of the alignment. So at the end of stage 2, we have several cross points, and we know the beginning and the end of the alignment. Then we will process in the original direction, finding more cross points in GPU. Then we'll go to CPU because it executes quicker, and we'll find more points. And finally, at stage 5, we will have all the points that belong to the optimal alignment. So now I will show you how we do that stage 1 in GPU. The dynamic programming matrix is divided into blocks, and a set of blocks will compose an external diagonal. In this example that you're seeing here, we have 3 blocks. So each external diagonal can have up to 3 blocks, okay? And each block will be computed by T threads, and each thread will compute alpha rows. So the CUDA kernel will be invoked to compute one external diagonal with multiple blocks. But here we have a problem, because the wavefront, recall that we have very few parallelism at the beginning, and then it increases and then decreases again. And if we invoke the kernel like that, we will lose a lot of parallelism because it is a rectangle. So we proposed not to use the rectangle, but the parallelogram. So what will happen is that the first invocation, kernel invocation, will stop at the last moment where we have the full parallelism. And then the next CUDA kernel invocation, we will start from this point using the parallelograms. And with that technique, we don't lose parallelism, only at the very beginning and at the very end. So it's very efficient. When we were computing this huge matrix, we noticed that some parts of it, the score is so small that it cannot mathematically lead to the optimal alignment. Here you have an example. Imagine that the score that I have is 100, and up to the end of the computation, I have 50 rows. And the best case is to have matches of all the characters. And the value for matches is 1. So if I use the cell up to the end of the computation, in the best case, I will have 150. But the best score is 230. So I don't need to compute the cell. But we will not do this reasoning by cell because it takes a lot of time. What we do is that we define block, we do this reasoning by block, and if we can prune the whole block, we do block pruning, okay? We also studied this technique, and we discovered that the pruning area is defined by 4 lines, F1 to F0, and it depends on the inclination of the line. This is built as long as we compute. This is the end of the computation. So the inclination will change as long as we compute. The publications for MASA-CUDAlign in 1 GPU, the first one was MASA-PPOP 2010. Here we were comparing the chromosome 21 and talking about 32 millions of characters and 47 millions of characters. We used an old GPU, but it was 2010, GTX 280, and this comparison took 21 hours. The metric used to compare Smith-Waterman algorithms in HPC platforms is gigacups, which means billions of cells in the dynamic programming matrix computed by per second. And here we have 20.3 gigacups. Okay, this is the publication for CUDAlign 2.0, IPDPS 2011. Here we obtained not just the score, but also the alignment of the same sequences in 18 hours, 18.5 hours. Using another board, GPU board, better, and the gigacups was 23.6. And finally, for 1 GPU, CUDAlign 2.1, the publication was in a journal, IEEE Transactions on Parallel Distributed Systems, 2013. Here I'm showing you the pruning area. So what you see in gray, we did not compute, but we were able to obtain the optimal result, even without computing it. What's interesting here is that if the sequences are not similar, we don't prune a lot because it depends on the score, and the score will not be high. If the sequences are very similar, we prune a lot, and that's what you see here. We compared the same chromosome 21 with another board, and now it took 8 hours with 52 gigacups. But we started from 21 hours. Now we are in 8 hours. Of course, it's better, but takes a lot of time. 8 hours is a lot of time. So we went to multiple GPUs. The strategy that we used is to do the multi-GPU wavefront. We keep the wavefront inside 1 GPU, and we add another level that is the multi-GPU wavefront. So each GPU will compute a set of columns in the matrix. We also have an overlap between computation and communication using communication threads and a buffer, okay? And that's the strategy that we used in stage 1. How we will compute do the traceback with multiple GPUs? Here we have a problem because stage 2, as I told you, we have the optimal result and its position, the optimal score. We read the row that's closer to it, we recompute until we find a point that crosses this row, only having this point, we recompute the other part and so on. We cannot compute all the parts in parallel because we don't know the points. So this is sequential. How do we do something that is sequential in parallel? We use speculation. So I'll show you briefly our speculation technique. Here you have the idea of our speculation is that the local maximum will belong to the global maximum. So here you have 4 GPUs. The last GPU has the optimal score, but the others don't. So, but each GPU has a local maximum. So each GPU will retrieve the cross points using the values that you see in red, that is the local maximum. So they will compute that. And also GPU 4 will compute with the correct value. When GPU 4 reaches the border column with GPU 3, it sends the value to GPU 3. If the value is the same, the speculation was correct, very good, we use what we calculated. Otherwise, we need to recompute. But recall that everybody's speculating. So GPU 3 speculated, and it can find a point in the border column with GPU 2 that is different from this one. And then it will send to GPU 2 that will do another speculation. So we can have many speculations, and that's why we call incremental speculative traceback. This is our design from the point of view of GPU I. GPU I will be idle for TA, waiting the wavefront to arrive in it, and then it will compute stage 1 in T1. When it finishes to compute its columns, it will be idle. And then GPU N, here stage 1 will finish, and then GPU N will compute, send the value to GPU N minus 1, and so on, until the value arrives here, the correct value. And then GPU I can do that using pipeline. But this is without speculation. With speculation, it's the same thing in stage 1. GPU I will be idle here, and then it will compute in T1. But as long as it finishes to compute, it will start speculating, okay? Then, at some point, GPU N will have the correct value, and will send to GPU N minus 1. If the value is correct, it will be very quick, and that's what you see here in the horizontal lines. If the value is not, because this is time, if the value is not correct, we need to recompute. So in our design, and we have this in the paper, we are able to, our rate of success in the speculation is very high, and we are able to reduce the execution time a lot. Okay, the publications for CUDAlign multiple GPUs. First, only the stage 1 without the traceback. We have 2 publications in PPOP 2014. It is a heterogeneous platform, GPU platform. And to compare the same chromosomes using these 3 GPUs, we took 6 hours and 28 minutes, and the GigaCup is 139. In CC Grid, we use it, you can see here a study of the performance in GigaCups. So the same chromosomes 21 with 16 GPUs, we took 1 hour and 20 minutes, and the GigaCups is 488. And this was the first time that we executed the Smith-Waterman algorithm for the chromosome 1 that we wanted in 2008. And only to obtain the scores, we took 9.09 hours in 64 GPUs. And here was the first time that we reached the teracup performance, 1.7 teracups. Finally, CUDAlign 4.0, the publication was in a journal, IEEE Transactions on Parallel Distributed Systems, 2016. We obtained not just the alignment, optimal alignment of chromosome 1, but all the alignments of the homologous human chimpanzee chromosomes. The comparison of chromosome 21 using 384 GPUs took a few minutes, and the best result that we had was the optimal alignment of chromosome 5. Here I'm talking about 180 million characters compared to 183 million characters. So it took 53 minutes, and the best performance that we got was 10.3 teracups. And we were able to obtain the chromosome 1 alignment that is here. Graphical, we also have the textual version. It took 2 hours in 384 NVIDIA M29 GPUs. In this comparison, we computed 56.9 petacells. So it's a huge, huge comparison. Here, I'm showing you the best performance for Smith-Waterman so today, okay, for HPC platforms. The best performance for FPGA is SW Riviera. It compares very small sequences, obtains only the score using 128 FPGAs. The performance is 6 teracups. SWMVM is the best performance for CPUs. It compares very small sequences, obtains the score in the alignment with 128 CPUs, and the performance is 0.9 teracups. The best performance, as far as we know right now for GPUs, is CUDAlign that I just showed you. We compare huge sequences that have hundreds of millions of characters. We obtain the score and the alignment with 384 GPUs. The performance is 10.3 teracups. And then we have Prince. Prince compares very long sequences, hundreds of million characters, obtains only the score, and it uses a custom design of resistive CAN. Processing in storage is a very recent technique, but these results that you see here, 53, is only in simulation. It does not have a real execution as the other ones. I can say that there are more than 100 papers in the literature in the last decades that discuss Smith-Waterman in HPC platforms. Okay, now I'll talk about what we are doing right now, that is CUDAlign with multiple GPUs and pruning. First, I'll show you our MASA architecture. We reorganized the code of CUDAlign, and we divided it in 2 parts, platform dependent and platform independent. And then we integrated the implementation. So now we have CUDAlign, OMS, OpenMP, and so on for several platforms. So here we are executing CUDAlign in multiple GPUs with pruning. The challenge is when we add block pruning, we can prune some parts of the matrix, and we only know that as long as we compute. And that, as you can see here, will lead to a heavy load imbalance. So recall that GPU1 sends values to GPU2, GPU2 to GPU3, and so on. So transitively, every GPU is dependent on the other. And we have a phenomenon that if there is a heavy load imbalance, the computation will run at the speed of the lower GPU. So this is really bad. What we are doing now is that the first step that we did is score sharing. Each GPU will compute the scores. And when GPU 0 sends value to GPU 1, it sends its best score also. This way we can increase the score quickly, in this case for GPU 1, and prune more. These are the results in Neuromicro PDP 2020, was in March. And we compared the chromosome 21 human chimpanzee in 4 GPUs Pascal in 56 minutes, and the gigacups is 680.81. Now we are designing a load balancing solution to tackle the dynamic pruning scenario. In our case, we will pause the execution at some points, evaluate the balancing, and then we will redistribute the workload. But there is a considerable overhead to do that. What we want to do is that we will use in case where the load balancing benefits are higher than the overhead. So it's not in all cases. Recall that sequences that are not very similar do not have a big pruning area. So for this, I will not I will do the static and will not do the load balancing. Only the sequences that are very similar. But we only know that as long as we compute. So that's the challenge. The strategy that we are designing right now, you can see here is the strategy, the traditional one that we use already without breakpoint. With breakpoint, we will compute here with one breakpoint the first half of the matrix. We will reevaluate and then redistribute the work. We have used, I thank Ganesan for that, and the University of Oregon, 2 machines with IBM Power 9 and 8 NVIDIA Voltas V100. And here you can see the results that we got so far. With 2 breakpoints is the best. We are comparing what I'm showing you, several chromosomes, but here is chromosome 20. The best result was 2.75 teracups in this comparison. What you see in light blue is the strategy that we are designing with 2 breakpoints. And what you see in red is the original CUDAlign without pruning. So we have an improvement of about 50% in the execution. So to recall, the best result in the literature for GPUs is the result for CUDAlign that we obtained in 2016, 10.3 teracups with 384 NVIDIA M2090. I had just showed you that we obtained 2.7 teracups with 8 NVIDIA GPUs. So it's a huge improvement with Power 9 also. So we estimate that with 40 NVIDIA V100, we are able to beat our best result for GPUs. And we estimate that with 256 NVIDIA Volta, we are able to beat the best theoretical result that was obtained with simulation with the resistive CAM. Now I'll show you briefly the CPU studies. We compared some, we have the MASA OpenMP. We have sequences that are smaller. We used 1 million base pair sequences. These are bacteria. And we compared IBM Power 9, Intel i7, and Intel Xeon in the platforms that we have, and in the Power 9 platform. So Intel i7 only have 4 cores, so the performance was not good, 16 minutes. Then we have a platform with 24 cores. Intel, it took 4 minutes, and in the IBM Power, it was the best result with 3 minutes. We are still doing the breakdown between these two studies in order to see what's the real difference, what happened here. So this is for executing our application, MASA OpenMP, in this platform. We also are doing a COVID-19 study that is different from the lung X-ray study that we saw in the previous presentation. We are studying the DNA, okay? Of course, the virus, it has an RNA, but what we are studying is that how the virus acts in the host, in the human host. So that's why we have the DNA. The disease is COVID-19, but the organism is SARS-CoV-2. The SARS-CoV-2 sequences, they are short. They have 300,000 characters about it. First, we compared the SARS-CoV-2 sequences obtained from several countries, Brazil, China, USA, India, Japan, etc. And we concluded that they are very similar sequences. So we decided to study just one and compare to the other coronavirus, MERS and SARS. Why? What the goal of the study is to define why the COVID-19 has such a high transmission rate. The others, MERS and SARS, the transmission rate between the humans is not so high. So we think that this is on the DNA sequence. So that's what we are doing. So we compare it, and even though the sequences are quite similar, there are regions of interest. Here you can see our tool. If the alignment is on the diagonal, the sequences are quite similar. But if you see the textual version, there are several gaps, and the biologists, they are studying this region of gaps right now, okay? So that was what I had to talk to you today. This work was not just done just by me, of course, but a lot of people. So I would like to thank first my former PhD student, Adam Sandes, and then my current PhD student, Marco, and my undergrad student, Bernardo Nascimento. These people are directly involved in the results that I showed you. Also, Jorge Teodoro, professor at the University of Minas Gerais, Maria Emilia Walter, who is a professor here at the University of Brasilia, and Eduardo Aiguade, Xavier Martorell, and Guilherme Miranda. Eduardo and Xavier are professors at the Polytechnical University of Catalonia, and they work at the Barcelona Supercomputing Center. So these people are directly involved in the work that I showed you, but other people work with CUDAlign and MASA, etc. So I'd like to thank Azedine Bukersh, Manuel Jaldon, Samuel Thibault, Genaína Rodrigues, Célia Haria, and two of my master students, Rafael and Gabriel, and many undergrad students. So this is a huge project. I also want to thank the Barcelona Supercomputing Center for providing access to the Minotauro GPU cluster, the XSEED platform in the USA for providing access to the Kinland full-scale system, where we used 384 GPUs. It was hosted in Georgia Tech. They turned it off. And now we also used the Comet cluster of Pascal, hosted at UC San Diego. I also want to thank NVIDIA Brazil for providing access to their platform. And also I want to thank IBM USA and the University of Oregon for providing the access to their Power 9 and Volta platform. The MASA code is available at GitHub. And here you can see some of the institutions and people that are using the MASA code, even GPU, CPU, and we have a version Xeon 5. So in Brazil, we have several institutions. We have in Croatia, in France, in India, Japan, Singapore, Spain, and the USA. So we are open to collaborations, and that's what I had to talk to you. Thank you very much. Now, are there any questions?
Professor Alba,
okay. Yeah.
Thank you for a very detailed presentation on biological sequence alignment with the Smith-Waterman algorithm and CUDAlign using Power9 system and the Intel-based systems. Thank you very much. And you know, there are questions in the question window. Already people did you know, ask about it. They are asking what is the goal of this Smith-Waterman?
Okay.
There's a, yeah.
Okay, so the Smith-Waterman is an algorithm that it compares sequences, okay? In this case, we are comparing DNA sequences. So the goal is to define how similar the sequences are. And it obtains a score, a similarity score, that the higher the better, the more similar, and it obtains the alignment. Let me go back, sorry. Let me see if I can go back here. So here you can see the alignment, okay? So this is the alignment that has the optimal score because Smith-Waterman obtains the optimal score. And the biologists, they want to study, here you have the two sequences. This one is the SARS-CoV-2 and this one is MERS. And here, as you can see, some parts exist in the MERS, but do not exist in SARS-CoV-2. And maybe this is causing the high transmission rate. So they analyze the differences. So the goal of the Smith-Waterman algorithm is to compare sequences and to say if they are similar and where they are similar and where they are different. That's what the alignment shows you. Here they are different. Here they are similar, quite similar. There are parts that are very, very similar, but I didn't put here because I wanted to show the differences. I don't know if I add. So this algorithm is, in bioinformatics, it is very used. That's what I can say. I don't know if I answered, Ganesan.
No, you answered, Professor. That's good. Thank you. Let's move on to the other question. You know, there are a bunch of questions people do ask. Panelists, do you have any questions for Professor Alba? Panelist, one of the panelists, Professor Jayaraman from IIT Madras also joined. And welcome, Jayaraman. Let me check on.
Yeah, can you see that?
Yeah.
I can. Yeah. Oh, hi. How are you?
I'm fine, madam. So yeah, it's a good presentation. So So I'm from combustion area. So anyway, so it's good.
Okay, thank you. So I'm seeing some questions here. The structure of the corona. I have a question about the structure. Yes, we don't compare. So we are comparing, how can I say, this is 1D comparison. We are comparing just the characters. There are other works, we have some works like that, where we compare the structure of the virus. That is the 2D structure of the RNA. And yes, it's changing. The COVID-2, it's changing. So there are some changes, small changes, but they can have a big difference on the behavior of the virus. So this is a work from people from Denmark. They have a center in RNA and they do the structure. They compare the structure of the RNA. The algorithm is more complicated than this one in terms of dependencies. But we use the wavefront and things like that. Okay, we can talk later. You can send me an email and I will show you not the corona results, but how to compare RNA 2D. And sorry, there are other works that compare the proteins and they do the folding. There is a protein involved in this virus that is the spike protein. And this is the protein that gets into the organism and from where the virus enters in the organism. So it's very studied. And this is another algorithm. It's not dynamic programming. It's molecular dynamics. It's always also a supercomputing application. And the question is how the protein folds. And we want to know how it is folded in order to do some medicines that will act in this protein. So it's another work. In this work, we are comparing just a sequence, but there is there is a lot of types of comparisons that you can do. Thank you. I hope I answered the question.
Yeah, thank you. Thank you.
The question and answers.
Yeah, thank you, Professor Alba.
Okay.
Yeah, certainly. And I have another panelist from Brazil also joined, Carlos Antonia. Carlos, do you have any questions for Professor Alba or for the team? The whole team is here.
Oh, I'm okay.
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 So, Professor Alba, I have a quick question.
Okay.
Well, I am Arghya Kusum Das from UW Platteville. So I am also doing the research on genomics, but not in the GPU side. So my research is a little bit on the error correction and assembling of genomic workload using de novo type of sequencing and everything. So I was wondering, as you were saying that you have a lot of whole suite of software package, do you have anything where we can, which I can use to accelerate the error correction or the instrumental error correction in the genomic sequence on top of GPU?
Okay, I know that in DNA assembly, that is the first slide that I showed you. So DNA assembly, I assuming that you have short reads, is Illumina
Right.
or PacBio?
My current project is like a hybrid error correction where I am leveraging the Illumina error for PacBio, correcting PacBio.
Okay, great, great. So first, this tool, we use it since the short reads are short, of course. You can use Masa OpenMP, but we use the CPU version to do not the de novo assembly. We have a reference, so we have a genome of reference, and we want to put this genome. So this was the problem. And we used it in the last step, that is the contig, the scaffolding, DNA scaffolding. So we do the semi-global. Smith-Waterman does the global alignment, but we can do with this tool, Smith-Waterman does the local alignment. We can do also the global and semi-global. Semi-global is the alignment that we use it to the contig. So in the last step, we have contigs that are longer sequences. And then we have at the end of the scaffolding, the DNA sequence. So yes, what I know, so I did not work in the DNA assembly problem, but I know people that work on it. They use Burroughs, Wheeler, they use graphs and so on. What I can say is that this tool can be used at the last step of the DNA assembly, which is a scaffolding. And if you want to collaborate, we can show you how. But the error, to compute the error, we will give you the alignment. And then with the alignment, you will see the error. I don't know if I answered.
Yes, yeah. I mean, of course, that was very helpful answer. That it is good to know that. another question just related to that, since you're providing all the alignment and everything. So when I am correcting the error of a PacBio long read sequence leveraging the Illumina sequences, one of the major problem is the huge size of this Illumina data set. I mean, so, well, I mean, although you have told that it is capable of handling the data set, like which actually needs 120 petabytes of memory. But what my question is, I mean, my alignment is kind of, let's say, it's a little bit raw. So I just try to upload the entire Illumina dataset in memory. Do you have any suggestion for that? I mean, is there any way how I can do the efficient memory usage or something like that? Possibly that's where we can collaborate together.
Yes, I think, but we have the same problem running out of memory, because we execute in linear space, but in the first step of the Smith-Waterman, we save some rows in memory, okay? But these rows, they are very big, so they have like 200 megabytes. So they are big. If I have a lot of rows, I will run out of memory. So we have a strategy that we call it hybrid. First, we store in memory. When we are reaching 90% of the memory occupation, we go to disk. So I think that's what I suggest. Not go to only, you should use disk if you don't have enough memory, but not just using disk. Go use the memory that you have, and then you go to disk, or to remote memories. You can go to remote memories too. So we have a strategy that does that. So we can, I think we can talk about it.
Sure.
Okay.
Thank you. Yes.
Thank you.
Thank you, Professor Agya, for the wonderful question. And there is another question, Madam. Let me see. Wellington Martins. I think he's asking about the experiments were done taking advantage of the NVLink or the PCIe.
The advantage of taking advantage of what? The PCI?
NVLink, the NVLink GPU.
Oh, yes. So the Volta GPU, for us, we are very happy. So we did not do a breakdown. We think the performance is fantastic. I can say for my application, of course, I can only talk about Masa CUDAlign. And we think that is because NVLink, yes, and also HBM, the stacked memory, and also the various cores that they have. So they have, I think, is more than 5,000 cores. And all what we noticed compared to Pascal was the HBM. So the memory HBM2 is stacked, and the performance very good. And also NVLink is much better. So the throughput is much better. What I can say is that Volta, compared to Pascal, is much, much better, okay? For our application, I can say. We are very happy with Voltas. We are waiting for the Ampere, but we are very happy with Voltas. Yeah. I don't know if I answered.
No, you answered, Professor Alba. Thank you. Any more questions from the audience and from the panelists? I think we are almost, on the time, to close the webinar. But anyway, Professor Alba, thank you again for your wonderful presentation, and really appreciate it. And I'm very happy that you are actually recently started using the IBM's Power9 system, and ready to share your experience also. Thank you for that. Really, thanks, Alba.
Thank you, Thomas. Yeah, it was a great opportunity to talk here, and also to work with you, to use the machines and share our experience. A very good experience. Yes.
Sure. And audience panelists, if you also want to get some experience on Power9 system with the Volta GPU, like how the Professor Alba experienced it, please, do send us an email. We will definitely, provide you access based on the, solutions, which you want to solve. And again, I would like to thank the presenters for the presentations today. Thanks to Dr. Alba and Lutz, Heinz, and Sandhya. Thanks to panelists, Mr. Jayaraman, Mr. Agia, and Carlos, as well as thanks to all the participants who actively participated in the webinar. We still have 131 members, as part of this webinar now. For the last 2 hours, a lot of technology exchange happened too. And looking forward to meet you all on June 26th webinar with Citibank. It's going to be a kind of a new experience, how one can become an enterprise architect. One of our senior Citibank executive is going to be sharing his experiences with IBM's the OpenShift product. And also we have June 29th, the OpenPOWER, a full day workshop, which is going to be happening in Europe as part of ICS 2020. I just shared that, the link and, and also the flyer as part of, the chat window. Please do take a look and, register yourself, to be part of that wonderful, the technological, the workshop. Thanks again. I really appreciate all your time and effort, and closing the webinar now. Thank you.
Thank you too. Bye-bye.
Thank you.
Thank you, sir. Thank you. Bye-bye.
Thank you. Bye.